Again, good afternoon, students. Now, today we will discuss about the second unit, spatial domain. So, in this concept, of enhancement in spatial domain, point processing, mask processing, and smooth spatial filters, sharpening spatial filters, combining spatial enhancement method, and another type of frequency domain, image transform, fast Fourier transform, discrete cosine transform, Carnot Love transform. So these are the techniques will become to how to this is image enhancement. After that image, how to this is image will move to this next level of enhancement level. Now I'll move to this discussion about this why spatial processing. So in this, say this picture, first picture, and second picture, third picture, a lot of contradiction about this is uh, uh, illuminance and clarity or brightness or shadowing some type of information regarding this pictures. So that the clarity will be improved, and then got this some type of filtering techniques or smoothing or sharpening to be come to taken from the next level of a spatial domain. So in this case, how to this is applying with the blurring image to darkness image. That is important today. This application how to this method. Just the input image from dull pictures is there to move to this sharpness pictures. So here this is spatial operator. What is this TN or dot product will come to change over to the type of this uh, pixels. So for example, here this is point processing means single pixel point to be without neighbors. If this is n0 of x comma y, this is a one single point. The single point will come to accessing from some more application from got this output is called a pointer will come to processor. Next level, the mask or kernel processing means surrounding neighbors. For example, in this pixel will come to middle pixel is a point. The surrounding neighbors n4 method up and down and left or right. You come to say this n4 x comma y or n8 the surrounding pixels of this middle center pixel. This is neighboring pixel. It will be allowing from mask or kernel processing. In this case, single points will come to process with the entire image, come to replacing from this one. Otherwise, the neighboring pixel should be changed over from the central pixel. This is called the operator from neighborhood of n of a given pixels. So this is this main method from point and kernel and mask processing. Here, spatial domain. Again, spatial domain processing for image enhancement. So, what is the major role of intensity of this transformation or spatial filtering? Now, intensity transformation or point operation, will be say already told about this, a single point. Map a given gray or color level U to a new level of V that will replace to single point. So you will come to this U means the input and then V means output. So V of transformation of this the particular U value. So here we say this is f of x comma y implies g of x comma y. So in this case x equal to 1 to m or y equal to 1 to n. This is the type of values of a coordinate value. U and V is a representation of this intensity values 0 to 255. So here this say this a point operation will be say memoryless, directionless operation. Here this output at x comma y only depend on the input intensity at the same point. If we say that the type of this value of this pixels the same transformation level. Thus the bring in new information may cause loss of information but can improve visual appearance or the type of the make features easier to be detect. Here this output gray levels, this is output gray levels of this V. So that is the inputs of U and output is V. You come to some type of this point operations. Here the intensity transformation of point operation, the two example we already saw this color space transformation and scalar quantization. Here we say this Lena image is a original image, is a RGB image. We translate it into grayscale image, and then grayscale pictures will move to this scale quantization. Color space will come to RGB to grayscale transformation. Again, grayscale to in scale quantization be improved. So this is the type of point based operation. Another case of point based is the image negative. V equal to 255 minus u. That case, all the maximum level separation of this the particular value. You got this, some type of the appearance of the photographic negative is there. 255, so automatically black to white, white to black. That's the cases will come to image negative. If we say this enhanced white or gray detail on dark region, especially when this black areas are dominant in size. For example, this is the original digital mammogram for breast cancer, breast image. We will move to this negative image to obtain this negative transformation. In this case, some type of courtesy of the GE medical systems to identification about this basic intensity transformation function. Here some of this basic grayscale level transformation will come to using from image enhancement, some type of input gray levels of or output gray levels of yes. The intensity to begin this root of negative, how do they say this a log value and the nth root and identity nth power and the inverse log. So depends upon this type of point operations. Here monotonic and reversible, compress or stretch certain range of gray levels. So here this log transformation depends upon this some type of the value v equal to c log of plus 1 plus u. That is a point operation. Will come to say the type of the Lena picture. Here this is post Fourier transformation of Lena. We will come to say this the type of pictures will come to project from the type of values. For example, in this MATLAB, I will say im equal to im read of Lena.png, a equal to absolute function we using from FFT shift FFT to of double of that particular image im. So automatically c equal to logarithm log function come to 1 plus double of im. That is means c equal to range of normalize of c. B equal to log of 1 plus a and b equal to b divided by max of b colon entire row of this the particular value. So the Fourier transformation spectrum like that is the result of this application of this log value. For example, here this is say the type of this function value to be depend from that particular Fourier transformation. In the result of this application of the log transformation, suppose this equation with the c equal to 1. So another one will come to power law transformation. Power law is this u of the input of this level. It means the gamma level will come to this level of power of transformation. C into u of power of gamma. So power law transformation function in practice, some type of this value to intensity to voltage of function as gamma to approximately will come to 1.8 to 2.5 value come to change over from the type of this power. Camera capturing distortion with gamma c equal to 1 minus 1.7. So similar devices curves in scanners and printers like that power law transformation. The power law transformations are also useful for general purpose of contrast manipulation, gamma correction. So another is another type of this important linear input appears from linear or displays. This is the method from calibration pattern plus interactive adjustment. Here this is a gamma corrections, that is a monitor to be implies what is the range will come to image as viewed on as a monitor. So this is another type of gamma correction. After correction, the what is the say of this that is monitor. Some type of calibration chart will come to that is just a linearity will come to say that a type of gray linearity change from black to white. So effect of gamma on consumer photos, here they say that is a boat picture. So come to say that's a 2 point L0 2.2 Here you say this is 0 and 1 divided by 2.2. Say some type of information we change over from clarity among this darkness to brightness. This is called gamma correction. So what gamma to use? Here say the type of this bone marrow pictures shall be V equal to C dot R power gamma. A level will come to change over from input levels. So gamma will come to say greater than 1 or less than 1. What is the resultant value come to the produce from your concept. So whether there is brightness will move to darkness. So more intensity transformations will come to like that log gamma. The closed form functions on 0, 1 can be more flexible. So here this is output gray level. So this is the type of contrast sketching. Here this say 0, L by 4, L by 2, 3L by 4 and L minus 1. So in this say that I will come to more flexible to change over from T of R. So contrast stitching to applicable from the type of information. Intensity slicing. So this transformation highlights intensities range A and B and they reduce all other intensity to a lower level. This transformation highlights the range A, B and preserves from all other intensity levels. So in this cases, how to this change over from that pictures? Here this is like that. This is the original picture for aortic angiogram. This is the resultant of this slicing transformations of the type illustrated in this figure. Another one will come to say the type of this informations to be depends upon this upper end of this grayscale, and the result of using this transformation in this figure you will come to say applicable from the type of pictures. So image bit planes. So one 8-bit bytes will come to say bit plane 7, most significant among this 7 plane, and bit plane 0 is a least significant bit. Will come to along with the type of a bit plane representation of this 8-bit images. So in this continuation, we'll come to say this type of bit plane representations. Here, this is one 8 bits. Each and every bit will be say this least bit is 0 up to 7. 0, 1, 2, 3, 4, 5, 6, 7. So this is a bit plane representation of 8-bit image. Each least significant bit is a bit plane 0. Most significant bit is called as a bit plane 7. So in this 8-bit plane, out of this representation of this image, see clearly we know from this is the bit plane of this pictures, like that to say the type of information. So slicing bit plane depends upon this relative importance of bits. How much of slicing depends of the image content useful in image compression. That's the type of this plane image reconstruction using of bit planes 8 and 7, between 8 and 7 and 6, and between 8, 7, 6 and 5. To compare with all the things, you will come to compressed of this image. So here this is say here image enhancement of spatial domain processing, between intensity transformation and then intensity transformation function based of the negative log gamma, intensities and bit plane slicing and contrast stretching, histogram equalization and matching, local processing, spatial filtering, especially will come to filtering basis, smooth filtering and sharpening filtering, unsharp masking, Laplacian combining of spatial operations. So here this gray level image histograms, you will come to say the type of histogram. Histogram is this normal thing. You will come to say that is one of the chart of relation between this number of occurrence in this particular grayscale value. For example, x-axis is the grayscale value 0 up to 255. Here this is number of occurrence 0 to 4500 maximum level. Up to the, sometimes it will come to say 99 or 100 or 111. We say this is 4500 times we point out in this picture. Rise dot diff. So in this figure, this say image IM is I comma 64 is a this is this coding is this MATLAB coding. This is this histogram. This is this picture, original pictures. Interpretations. What is this interpretations of a histogram? Normally, histograms of different type of image, like that dark image, contrast image, and exposed image. So, under this exposed and overexposed, we'll come to say the depending upon this unbalanced histogram. They dynamically range from low contrast image, the narrow luminance range, underexposed image, concentrating on the dark side, overexposed image is concentrating on the bright side. So this is a balanced histogram to gives us more pleasant look and reveals rich details. To compare with all the histograms, this is high contrast image. This is a contrast stretching. Stretch is over concentrated gray levels, piecewise linear function, where the slope in the stretching region is greater than 1. So here they say the type of information of beta equal to transformation of alpha. Alpha is this under level of this intensity values 0, alpha 1, alpha 2 and L minus 1. Beta 1 is beta 2 and L minus 1 is a transformation function. Here this is like this input image, this is this output image. So change over from the histogram level out to this variation between this histogram equalizations. So in practice, you will say this intensity about this good image, adjustment of this color levels, the type of this level of values. You will come to say good image, a uniform histogram spanning a large variety of gray tones. Can we figure out a stretching function automatically? So this is another type of questions here we are raising here, histogram equalization. So what is the main goal of this histogram equalization? Map the each luminance level to a new value such that the output image has approximately uniform distribution of gray levels. Uniform distribution means up to 0 to 1. That is the level of uniformity to be distribution from all the intensity value. So to decide properties, monotonic means will come to non-decreasing function, no values revised. 0, 1 to implies 0, comma 1. So the range will come to say this output range between the same as the input range. This PDF format distribution function will come to say the type of uniformity. The cumulative distribution from what is say the range will come to say this high level. Histogram equalization is a normally uniform distribution. Like that, they'll be using from the type of the function of V, A, F, Fv of V, capital V. Normally, that is uniform. It will be under this level of V, the 0 to 1. So implementing histogram equalization depends upon this value to be come to supporting from U, that is a processing value, and then V is a rounding of or uniform quantization, V dash the output. So compute from histogram and then equalize and then round the output. It is a toy example. You come to this level of R level 0, 1, 2, 3. Up to this level, you will come to say that depends upon this the level of values. Toy example. The tuning levels will come to change over from the type of T of R, and then different type of a rounded value 1, 3, 5, 6, 6, 7, 7, 7 values will come to point out from histogram equalization. Histogram, and maybe there's a dark image, maybe the light image, maybe there's a low contrast image, maybe the light contrast image. Depends upon this range, will come to the stretching of this equalization. The contrast stretching versus histogram equalization depends upon this contrast versus histogram equalization. The normally histogram equalization uniformly distribution from all the intervals of this uniform input gray levels. Function form reversible from loss of information input or output. Histogram matching is another type of concept. You'll come to say that a output of specifically you'll come to little bit should the graphical interpretation of this mapping. The time you'll come to say the type of PDF, you'll come to say the type of information to intermediate steps uniformly to distribution from random variables. So both histogram matching to be example like that will be intensity or input intensity as the level of equalization. The histogram equalization to be supported from the type of values. Local histograms. So problem global spatial processing not always desirable. Solutions apply from point operations to a pixel neighborhood with a sliding window. So depends upon this is the type of original image, the different type of windows, window 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 window slicing will come to this single 3 by 3 neighborhood size. This original features the resultant of this global histogram equalization. The result of this local histogram equalization to apply it from neighborhood of size 3 by 3. The histogram equalization not always is desirable. That will become to apply from that particular image. So, what is the major role of this information here? The image enhancement, spatial domain processing, intensity transformations, and then what is the negative log, comma, intensity subpixelizing and the contrast. Histogram, you will come to equalization, matching, local processing. Then I'll move to spatial filtering role. Filtering basis, smoothing filters, sharpening filters, and unsharpening masking Laplacian. So here we come to say spatial filtering. Spatial filtering in image processing is a nearby this neighborhoods. For example, the central window is a W of 0, 0, and the upper and the lower we say this the level come to 0 to be maintained in this y-axis, and the left hand side is maintained from 0 is the y-axis. Some type of upper of this value of y is -1, lower level is +1, left side is 1 and then right side is -1 of this window. So in this say this is a cross diagonal, we will say this the type of this value always will be upper, so always 1 or -1. So here this positive one for y axis and then x axis becomes -1. Here this is a -1 of x axis, both are will come to -1. Here say always +1. Here this is x will come to +1 and then a -1 from y. We will to say that the filter coefficient of this the type of filter mask, each and every image pixel will become to highlighted from the type of this value of amplitude functions. So in this say here this is f of x comma y is a middle value. So depends upon this pixels of image section to be under this filters. Kernel operator is a filter mask. We'll come to say the type of spatial filtering. The spatial filtering will come to say f of Tn of this value to become to supported from the type of a work of this kernel. Smoothing or image averaging. Like that here this is smoothing operator to become to the sharpening to smoothing. Smoothing you will come to say it's 1 by 9 into all kernel becomes 1 and then 1 by 6 into the different type of this kernels will come to partially rounded off this value. So now we will come to say 1 2 1 2 4 2 and 1 to 1. Depends upon this value of a smooth operator will come to working from low pass filter leading to softness of the edges. So here we blurring or dull image will come to the smoothing operator. Spatial averaging can surpass noise. So image with IID noise y of m comma n equal to x of m comma n plus n of m comma n. Averaging v of m comma n equal to 1 divided by nw sigma x into m of m minus k comma n minus 1 plus 1 divided by nw sigma n of m minus k comma n minus 1. So noise variance will come to applicable with the SNR improved from this factor of this NW. So smoothing operator of different noises. This is the original. It will come to this is this operator. Will come like that. The different size of this smoothing operator: 3 by 3, 9 by 9, 5 by 5, 15 by 15, and 35 by 33, 35. We will come to directional of this smoothing. The problem with the simple spatial averaging mask edges get blurred. Improvement will come to like that restrict of this uh, restrict of the smoothing to along edge direction to avoid filtering across these edges. So directional smoothing to compute spatial average along several directions take the result from the direction, giving the smallest changes before and after filtering. So other solution using from explicit of edges directions and adaptive filtering accordingly. It will say this the type of this non smoothing operator. Non-linear smoothing operator will come to say the median filter. A median filter like that says epsilon over a small window of size NW, x cap equal to sort of x. That is, it will come to the epsilon value, will come to highlight it from the type of this value of this result. Always will come to sorting of this value. Sorting of the value to highlight it from which one is the mid value of this uh, particular sorting elements. So identify this, for example, 3 by 3, the 9 elements are there, mid value come to say fifth element, the fifth element to replace to central pixel. This is called, it will come to median filter to applicable from the non-linear application. So non-linear is the median of x of m plus y of m, not equal to median of x of m plus median of y of m. So in this odd window, we say this any type of commonly used from 3 by 3, 5 by 5, 7 by 7. So 5 pixels plus shaped window. So even from the type of this average of two middle values of this output. Other order statistics, minimum, maximum, x percentiles. This is another type of a non-linear median filters, non-linear smoothing filters. So another type of median filters example, median filtering resilient to statistical outliers, yield curves from less blurring and simple to implement. It's a circuit board of X-ray of the pictures of circuit board. So corrected by salt and pepper noise and the noise with reduction with the 3 by 3 average mask, noise reduction with the 3 by 3 median filters. So in these cases, we'll come to say the type of filtering techniques. Image derivative and sharpening. So in this intensity level, the lot of edges is there. It will be constant intensity transaction ramp. Ramp and step is a major importance of edges from the particular first order or second order derivatives. Here the scan line, you will come to say the type of information from the scan line. Here they say 6 to 5 means minus 1. 5 to 4 means minus 1, 4 to 3 means minus 1, first order derivative, 3 to 2 means minus 1, 2 to 1 means minus 1, again 1 minus 1, 0, 1 minus 1, 0, again 1 minus 1, 0, 1 minus 1, 0, 1 minus 1, 0, 1 to 6, 5, plus 5 to be increased, again 6 minus 6, 0, 6 minus 6, 0, 6 minus 6, 0, 6 minus 6, 0. So now we will move to second order derivative minus 1 minus 1 minus 1 0 0 0 0 up to that level minus 1 to 0 will come to plus 1 will come to specifically to highlight from the 1. The same thing minus 5 or plus 5, that is the range of 0 crossing levels. So this is the first order derivative dou f divided by dou x, that is the resultant of f of x plus 1 minus f of x. Dou square f divided by dou x square equal to dou f divided by dou x of f dash of x minus f dash of x minus 1. The resultant value of f of x plus 1 plus f of x minus 1 minus 2f of x. So that's the resultant of this second order derivative. So edge and the first order derivative, edge is the pixel locations of abrupt luminance changes. So here this is a spatial luminance gradient vector. A vector consists of spatial partial derivatives along with the two orthogonal directions. Gradient gives this direction with the highest rate of luminance range. Representing edges, edge intensity plus the direction. Directions of this method will come to analyzation from the type of example of different intensities and directions. Then find the best matches, measure the transactions along with the two orthogonal directions. So the edge detection operator will come to analyzation from the different type of this mask Z1 to Z9 to connecting with the delta F, Gx and Gy, dou F, dou X, dou F, dou Y. So in this norms of F of X, yeah, delta F approximately will come to this norms of G of X plus G of Y. In this Robert operator or any type of Sobel operator will come to -1 0 0 1, then 2 by 2 matrix from Robert operator. Sobel operators 3 by 3 regions of operator for kernel -1 -2 -1 0 0 0 -1 to 1. The inverse of this matrix will also be supported from Sobel operator. So edge detection based on this Roberts and Sobel depends upon this highlighted from the type of spatial domain. So again we will come to say the type of second order derivative in 2D. So image Laplacian will come to analyzation from delta square of f equal to delta square f divided by dou square f divided by dou x square plus dou square f divided by dou y square. So elaborate the second order derivatives in this equation will come to say with respect to x and with respect to y. So delta square f both will come to combine with the y and x application. So finally, the filter mask to implement it from digital Laplacian, the Laplacian of Roman ruins will come to say the type of the information from the particular thing. Another one, unsharp masking. So unsharp masking is an image manipulated from the techniques of for increasing the apparent sharpness of photographic images. So the unsharp of this name derives from the fact that the technique uses a blurred or unsharp positive to create a mask of the original image. The unsharp mask is then combined with the negative, creating a result image sharper than the original. So here this original signal, this is a blur signal, unsharp signal, say another one sharp signal. So blur the image separate the blurred version from the original. This is called the mask. So add the mask to the original one. So next we will move to eye boost filter. In this is the buffoon image. Will come to this average. Will come to smoothing filter, and to identification of a negative to come to minus. Will come to say the type of this filtering techniques. It will come to edge detection or whatever anything. Will come to unsharp techniques. So it will come to resultant of this one. Will come to add it from input image. Automatically got this the type of unsharp mask from eye boost with A1. So in this case, central pixel value always A plus 4, A plus 8. Unsharp. Unsharp mark example, this is the moon of 25th August 2005. In this day, moon should be moon with the unsharp mask applied. This is unsharp mask example. What is the basic for a eyes after the eyes forming on this 13th with the unsharp mask. So what is the major summary of this one? Spatial transformation and the filterings are popular methods for image enhancement. Intensity transformation, intensity transformation function, negative log, comma, and everything is there. So here this is a combining from facial operations. This is a sharpness to identify this model, and now stop this topic to this portion. Thank you. So Gonzalez, Rafael Gonzalez book, he'll say this smoothing spatial filter, also called as averaging filters, especially the mean median mode. It will help of this mean or averaging helpful to reduction from the noise and the noise reduction or unwanted irrelevant information to move to this to remove from this particular feature. That is the help of this smoothing. applications. So here this low pass filters are based on this box on the Gaussian kernel, both of which be separable from the particular information. Box filter kernels will come to like that the type of information to 3 by 3 model m by n box filters m by n array of 1. You will come to the low pass filtering the box kernel, we say this the type of pictures 1024 into 1024, the test pattern of size. So depends upon this filtering from both low pass filtering 3 by 3 and 11 by 11 and 21 by 21 respectively. So each and every time you will come to say the type of this kernel to zero padding result will come to say analyzing from the type of a smoothing of this function. So here there is a distance from the center of this various size of this square kernel. So 0, what is this as relevant square format. So in this case, before case 3 by 3, 5 by 5, 7 by 7, and 9 by 9, and 11 by 11, and so on. In this case, the type of this m by m is this could be pointed from the size m equal to n. So the type of this value will come to square matrices. So here they say the type of informations to identification among this smooth filtering. So already discussed about this previous concept in this work. Mean standard deviation, the low pass filtering of Gaussian filters. So comparison about this Gaussian and the box filter smoothing characteristics. So among this particular features. So smoothing performance of this kernel of this image like that will come to change over from shading correction with the low pass filters. Another already will be discussed about order statistics or non-linear statistic filters. Especially if they come to impulse noise will be come to remove. That is especially say median filter is a median filter is say this example of non-linear filters. Linear filters will come to say this a type of a minimum or maximum filters and the type of information like that non-linear combination. And the low pass will be the smoothing, high pass the sharpening. So high pass the sharpening of spatial filters. In this case, everything the pixels range will come to highlighted from the sharpness of these pictures. Here this is the X-ray circuit board by the salt and pepper noise. Noise will be reduced and then Gaussian low pass filter kernel sigma equal to 3. But you will move to this higher level, high versions of foundation depends upon this ramp and the steps, discontinuities of this particular feature. So must be 0 in this area of constant intensity, must be non-zero on the onset and the end of the intensity step or ramp. Must be 0 along intensity is called a ramp. Dou f divided by dou x f of x plus 1 minus f of x. So in this representation of this sharpening filters depends upon this value, first order derivative and the second order derivative. So you using this type of this image second order derivative of sharpening the Laplacian format. So among this the Laplacian kernel come to a nearest of this neighbors of this surrounding pixels to come understanding about this Laplacian role. The image sharpening using Laplacian. Blur image of this moon, north pole of the moon. We will come to say the type of information to be produced from the level of C value -1. We will come to produce the intensity of this level, unsharp masking and high boost filtering. So blurring the original image, subtract from this blur image from the original and finally add the mask to the original. So here this say the type of example from original image and blur image, unsharp image, sharpening image. Unsharp image will come to using from your original picture size is 600 into 259 pixels. So second one is image blurring using from 31 by 31 Gaussian low pass filter with the sigma equal to 5. Next one is mask. See, the resultant of the unsharp is a mask using the particular equation k equal to 1. Finally, the eye boost filtering with k equal to 4.5 highlighted from that is this face of this picture. So using first order derivatives of image sharpening and the gradient, that is the help of the type of formulas. And the next we will come to say the type of first order derivative operators. This Robert cross gradient operator based on the phase directions or any information of mass. Sobel operator. So everything will come to say the type of picture from transformations. Like that, for example, your example of that is the topic will come sharpening spatial filter, combining spatial image enhancement tool. For example, that conditions will come to say that using gradient of image enhancement. So in this reflection from the type of informations. So high pass band reject band pass and then filters from low pass filtering. So a low pass filter or high pass filter becomes exactly the opposite manner. The high pass filters all the frequency below this cut off the value of U0. So in this transformation, we say this is the type of low pass filter. So in between cases from pass band and a stop band is called a low pass filter. High pass mean first is stop band, another one is pass band. The next band reject mean the two pass band in intermediate stop band. Band pass means the two stop is the middle is pass band. This is called pass band filter. Low pass, high pass band reject that depends upon this is value. So 1D spatial low pass filtering and then combining for spatial enhancement method. With a few exception cases, you will come to combining blurring and with the thresholding to focus from individual spatial domain processing approaches. For example, the frequency of the given task will require application of several complementary techniques. In order to achieve this acceptable result in this section, we illustrate how to combine several of the approaches development thus far in this chapter to address the difficult image enhancement task. Because anyone who are filtering this technique, the spatial filtering the zero plate of image low pass filter result is the same come to continuity from the type of high pass filter result. So in this band reject and the band pass and then finally image with intensity scale. So why to say this the type of image transformation to along with the type of this Laplacian, sharpened and then Sobel. Like that the type of medical images to be supported from first order and the second order derivative. So in this case the type of information the Sobel image or mask of the image will come to post with the type of analyzation. So finally, we say the summary of this information. What is this image intensity transformation and the spatial filtering? This topic is a very important change. It will be enhancement of this particular image to be provided with the both low level and then the type of this smoothening and the sharpening to be supported from that type of work. Thank you.